Essay 3.6 Trigonometric Identities. So this section of the curriculum focuses on the trigonometric identities. So Pythagorean identity, as the name suggests, are derived from the Pythagorean theorem, and according to this theorem, in any right-angled triangle, the square of the hypotenuse is equal to the sum of the squares of other two sides. This theorem can be applied to trigonometric ratios, and that results in the Pythagorean identity. So with this section of the unit, we're going to learn more about the Pythagorean identity along with their proof, examples, and more practice problems. So going back to the right angle triangle in the unit circle, so here we have right angle triangle inside of the unit circle. And one other thing that we can do here is applying the Pythagorean theorem. So we can apply Pythagorean's theorem to this triangle. Okay, so we know that Pythagorean theorem is a squared plus b squared equals c squared, right? So in this case, we know that from here to here is cosine square, from here to here is a sine square, and we have the radius 1, right? And we do also know that this is right triangle, so we can derive the equation of the sine square theta plus cosine square theta equals 1. And this is available in your formula booklet. However, let's try to derive the Pythagorean identity. Okay, so we are going to prove the Pythagorean identities using the Pythagorean theorem. So let's consider a right triangle ABC. So I'm going to draw the right triangle here, and then I'm going to label it as A, B, and C. And I'm going to identify this angle here as theta, and this side as A, this side as B, and this side as C. So now we're going to assume that the line AB is equal to C, right? And the line BC is equal to A, the line CA is equal to B for our convenience, and we're going to assume that the angle B is theta. Okay, so in this figure, we know that the opposite side of the angle B is the B, small b, and the adjacent side of the angle theta is the small a, and the hypotenuse is the C. So let's write this as adjacent side of theta, and B as the opposite side of theta, and C is our hypotenuse. Then let's first define all trigonometric ratios which are further useful in deriving Pythagorean identities in trigonometry. So we can say that sine theta is equal to opposite over hypotenuse, which is equal to B over C. And we can say cosine theta is equal to adjacent over hypotenuse, which is equal to A over C, and tangent theta as opposite over adjacent, which is equal to B over A. Then, using this information, let's prove the Pythagorean identity. Sine squared theta plus cosine squared theta equals 1. Okay, so applying the Pythagorean theorem to the triangle, so we are applying, the step 1 is applying the Pythagoras theorem to the triangle. Then we get a squared plus b squared equals c squared, right? Then we can divide each term on both sides by c squared. So let's do this. So we're going to divide each term on both sides by c squared. So we do a squared divided by c squared plus b squared divided by c squared equals c squared divided by c squared. This will give us a divided by c squared plus b divided by c squared equals c squared c squared. It gets simplified to the 1. So we know that previously identified information. We do know that the a over c is equal to cosine theta and b over c is equal to sine theta. So we can replace these letters with cosine theta squared plus sine theta squared equals 1. Then we know that this is same as cosine squared theta plus sine squared theta equals 1. So hence proved. Okay, then let's do some examples. So we know that Pythagorean identity, the formula that we just defined is the sine squared theta plus cosine squared theta equals 1. This is the formula that we just defined, and it is also available in formula booklet. So let's start with the example 1. So here it says that if sine theta is equal to 3 over 4, we need to find the cosine theta. So since we know that the sine squared theta plus cosine squared theta equals 1, we can say that we can replace the sine theta with the 3 over 4 and square it plus cosine squared theta equals 1. Then this is also equals to cosine squared theta equals 1 minus 3 over 4 squared, which is equal to 1 minus 9 over 16. And this is equal to 7 over 16. So we do know that cosine squared theta is equal to 7 over 16, which means the cosine theta value is same as we're going to square root to both sides. So we know that cosine theta is equal to plus minus square root 7 over 4. Okay. Okay, now then let's try the example number 2. We need to solve the 2 sine square x equals 3 over 2 minus cosine square x. And the range of the x is x needs to be greater than negative pi over 2 or less than pi over 2. So let's do this in a new page. Here is we need to isolate that the sine square x and cosine square x, right? Because our ultimate goal anyway is identifying the x value. So we need to simplify this as much as we can. Okay, so let's move cosine square x to the other side of the equation. Then we get 2 sine square x plus cosine square x equal to 3 over 2. Then we can replace the cosine square x with 1 minus sine square x because we can use the Pythagorean identity. The sine square x plus cosine square x equals to 1. And the reason why I got 1 minus sine square x is I simply move the sine square x to the other side. Then we do know that cosine square x is equal to 1 minus sine square x. So we can replace the cosine square x with 1 minus sine square x. Then we get 2 sine square x plus 1 minus sine square x equal to 3 over 2. Then these two get simplified and we get sine square x plus 1 equals to 3 over 2. And I can move plus 1 to the other side. Then we get sine square x equals to 3 over 2 minus 1, which is equal to 1 over 2. Then we do know that the sine x is same as, because we can square root the both sides, sine x is equal to 1 over square root 2, or, so since we cannot have the radicals as a denominator, we have to change the format, right, of this answer. Then we get the final answer as a square root 2 over 2. And don't forget the plus minus. So the sine x is equal to plus minus square root 2 over 2. Okay, then now we need to solve for the x value. Okay, then let's think about the sine x graph. So here I have sine x graph. Okay, and we do know that the sine x graph is getting intersected with line plus square root 2 over 2 and line, another line that is negative square root 2 over 2. Okay, so these lines are approximately 0.7. So I'm going to draw the lines right here. Okay, and the top green line is square root 2 over 2 line, and the bottom one is negative square root 2 over 2 line. Okay, and we know that the x value has a range. It needs to be between negative pi over 2 and the pi over 2. That means the values that we are looking for are between this value, this line, which is the negative pi over 2, or the pi over 2. So you can see that there are only two answers possible, one here, another here, right? Then using the unit circle, we do know that when we have first quadrant, right, we do know that when the angle x value is equal to pi over 4, we get our first sine x value equals to square root over 2. Okay, so this is your first x value, and we do know that another x value happens in the negative side of your graph, right? And then we do know that this is the point, which is the opposite point from the pi over 4, or the negative point of the pi over 4. So we know that x value is equal to negative pi over 4. Okay, so there are two answers for this question. Okay, then let's try some IB question. So here I have IB question from year 2016. So we have sine theta value that is equal to square root 5 over 3, where theta value is acute. So since the theta value is acute, that means we can use the Pythagorean identity. Okay, so question A, let's find the cosine theta value. So cosine theta value is unknown, but we do know that the sine theta value is equal to square root 5 over 3. So using the Pythagorean identity, which is the cosine squared theta plus sine squared theta equals 1, we can identify the cosine theta value. So we're not sure of the cosine theta value, but we do know the sine theta value is square root 5 over 3 and is squared, right? Then we can say that cosine squared theta value is same as 5 over 9 equals 1. So cosine squared theta is same as 1 minus 5 over 9, which is same as 9 over 9 minus 5 over 9. So it's 4 over 9. So it means cosine squared theta value is same as 4 over 9. And when we square root the cosine squared theta and then 4 over 9, we get cosine theta value equals to 2 over 3 plus minus 2 over 3. Okay, so now we know that cosine theta value is equal to positive 2 over 3, or cosine theta value is negative 2 over 3. So, but however, we know that the theta value is accurate, right? It also means that this angle value needs to be accurate angle, right? So using the inverse cosine, we can find that the angle for the angle when we have a 2 over 3 as a cosine theta value, we know that this value is equal to 48.1 degree. However, when you have a cosine theta value equals to negative 2 over 3, we know that inverse cos 2 over 3, negative 2 over 3 gives approximately 131.8 degree, right? So cosine theta that has a negative 2 over 3 as its solution is not correct answer, as it gives the obtuse angle. Okay, so your correct answer is the cosine theta value equals to 2 over 3, as the theta is equal to 48.1 degree. Then let's do question B. Now we need to find the cosine to theta value. So cosine to theta value means we need to use the double angle identity, and out of all three cosine to theta double angle identity formula, I'm going to use the one that has only the sine. Okay, so means I'm going to use the cosine to theta value equals to 1 minus 2 sine square theta. The reason is, even though we calculated the cosine theta value in question A, since the sine theta value is the one that is given in the question, I like to use the sine theta value. Okay, so cosine to theta is same as 1 minus 2 sine theta value square root 5 over 3 square. This is same as 1 minus 2 square root 5 is 5 and 3 square is 9. So we get 1 minus 10 over 9, which is same as 9 over 9 minus 10 over 9. So our cosine to theta value is same as minus 1 over 9. And that's the final answer.